All right, looks good.
Good morning.
Good morning, everybody. So welcome to the webinar from K2 Systems. We are very happy to introduce our new flat roof system to you, the Dome V. Yeah, Dome V. It is the 5th generation now of our flat roof systems. And but before we go into detail, probably a quick introduction. My name is Marco from the product development.
And I'm Ronnie from technical sales. And after the first part from Marco, I will introduce to you later our planning software based on.
Exactly. So let's have a look at our agenda for this next hour. First of all, I will show you some slides, but very quick. I will go in theory into the different components of the system, introduce the system to you, and after that we will switch the camera and have a look at the actual parts that are lying behind me here on the table. And as Ronnie mentioned, in the end we will plan together a project in our planning tool based on, which is, by the way, free of charge. You can use it. It is web-based, so you don't need to download anything. You can work online with this software. Just go to our homepage and you will get access data. All right, let's go to the next page. So here are the two different systems. Both is the family of Dome V. One is the D Dome V and one is the S Dome V. Both have an inclination of 10 degrees. D stands for double. That's what you can see on the left-hand side. And S stands for single on the right-hand side. But as most of the single elevated projects face to the south, also the S fits very well for south direction. Some major improvements that we did compared to the standard version of Dome. We modified the geometry completely to have a better absorption of tolerances. This is a very important matter. The thermal expansion in different directions. You have the temperature difference between day and night, winter and summer. So the aluminium is constantly in movement, and these movements we can absorb with this very special geometry that I will show you later with the actual parts. It is a short mounting rail system with integrated ballast trays, so you don't need any additional parts to place the ballast, the stones. You can place those stones directly into the rail. The rail is based on our speed rail design, but now with additional wings on the left and on the right to cope with the ballast stones. Then a very big feature is the new flexible EPDM support pad. So instead of the usual pads made from recycled material, we decided to go for a better material, a pure EPDM material that has no chemical interaction with any foil or roof cover. So here, needless to say that you don't need any, in case you wonder, you don't need any aluminum layer here with this EPDM pad. It has this honeycomb structure that compensates tolerances and movement of the aluminum, but at the same time has also a better friction coefficient, and therefore we can reduce the ballast needed for the array. The parts are also designed very small, that can be connected together later on. The small parts, the main focus on the small parts was to have a lower transport volume, which reduces logistics costs. This is very important as we ship our mounting materials to all different places all around the world. So it is very important to reduce transport volume and transport cost. This was a big requirement when going into development for the system. Of course, it is, as usual, aerodynamically optimized based on wind tunnel test. Yeah, here are the different components in a close-up. The speed rail with a different geometry now, the honeycomb EPDM mat, and the different dome parts. On the left hand bottom you can see the two clamps, the mid clamp and the end clamp. They are based on our mini clamp. You probably know it from the mini rail. So those have a variety of from 30 to 50 millimeters. So basically one clamp fits all your panels. Same for the S-Dome V. Of course, it is a modular system with a lot of common parts. For the S-Dome, of course, the windbreaker is one additional part that you would need here. Then we have a look at some references. We introduced the system for the first time at the Intersolar this year in summer. So in the meantime, we have shipped out a couple of large projects and realized those projects. So we're very happy to receive good feedback from our installers. Of course, these feedbacks are very valuable to us and will be taken very seriously to constantly improve our system. So here we can see a 200 kilowatt system S-Dome in Hanover, Germany, and here a D-Dome installation on this rainy day. All right, then I suggest we switch over the camera and have a look at the parts. All right, now we have the parts here.
Two examples of the different V-Dome systems. The S-Dome single elevation here.
And the D-Dome here, yeah, as mentioned before, Dome V.
So the parts, the examples here are original, except the rail, of course, it's a little shorter than it actually is in reality. But all the parts you can see here, they are already assembled for you to have a look. And the special thing is you only need one screw based on our MK2 and bolt system. We have these parts, you take them apart.
So this is how the system will be delivered to you. It comes, as mentioned before, it comes in single small parts, which makes it very easy for transportation. Then the first step would be, or let's introduce this one again. You probably can see it on this smaller part. We have the structure here. So the movement of the aluminium can be absorbed and not be taken or transferred to the roof itself.
Which is good for the roof surface, for the foil, so the foil is not forced too much by the system itself.
Exactly.
And anyway, this mat has a much better friction coefficient than the older mat. You can just see it easily. It's quite hard to move compared to the older mat. one more word about the friction coefficient. I said it's better than with the old mat, but in reality I highly recommend to measure this coefficient always. You can use the friction coefficient measurement tool. It will be a good invest. It's it saves you much work and much money, because if you know the friction coefficient of your roof in reality, you only buy the stones you really need, and you only bring these stones to the roof, and you don't bring some extra stones because you just didn't know the friction coefficient.
All right. So
use the tool.
Yeah. First step in installation would be to apply the rail onto the mat, just like this. And then, as Ronnie mentioned, it's the only screw or bolt connection here. You turn in this nut and then place the basic part on it with the screw M8. It's still loose now, so you can still move it. And then later on, when you place the module, or actually you measure out the position on the rail and then fix it. Next step would be this part here. It's the upper part. You can't put it in the wrong way, so it doesn't fit like this. You can only put it in the right direction. You can't do any mistakes. And now it is still loose. You can work like that in the middle of a block, in the middle of an array. But at the corners, we plan usually with this little clip. Very easy to be installed. And now this is a fixation for this upper part. So you can do the same again. Slide it in, and it's already fixed. So this clamp also works as a bonding tool.
Yeah, and on the back side here you see the place for the windshield for the S-dome.
Yeah, just like that.
Also very easy to be fixed. Okay, let's come to the other part, to the counterpart. Of course, this is the top part of the module, of the elevation, and then you also have the lower part. It looks like this, and as we mentioned before, we have the only bolt connection here. We don't need an extra bolt for the lower part. You just place it in, you slide it in, or you can
turn it in,
and then it's still loose, and it gets fixed by this bolt of the end clamp. Here we can
exactly
simulate our module frame with this little tube. And
just simulating. So this would be the module frame coming from here to here.
And now it's still loose, but as soon as I fix the bolt, then this part will be fixed too.
So this means that when you fix the module on the system with the module clamp, you will automatically also stiffen the whole system along with it. So it's really just this one bolt is the only bolt for the whole system, and then of course the module clamps.
Yeah, and it works just because of the little tension within this part. It's not completely flat down here, and once you fix the bolt, you bring some tension, and so these wings here are pushed down, and this part in the middle part is pulled up. So yeah, that's why you don't need extra bolts here.
Correct. So this is the south-facing system with an extra function here for a windbreaker, and the same will work also for the double inclination, so the east-west system. And what needs to be mentioned here is that this V that we have here can breathe, so to say. It can compensate movements for heavy wind loads, for example. It can compensate those movements going on with the aluminium on top, so that in the end, through this protection mat and the special geometry on here, the movement will not be taken to the actual roof. So pretending this would be our rooftop, no forces will be applied into the roof.
And of course it's the same with the S-dome too. One word for the middle and end clamp. Maybe if you know our mini rail system, this is the clamp we also have been using for our mini rail system for several years. It fits into this channel, and it's good for all frame sizes between 30 and 50 millimeters. So one clamp fits all.
Correct.
Okay, one last word maybe concerning the ballast. This rail is, so to speak, a modified speed rail, and we added these wings here. So because of these wings, it's what Marco mentioned before, we don't need any additional parts for most projects. If you have a lower ballast or middle high ballast, then you would be able to place the ballast stones in between these wings. And so it's safe, you don't need any fixation or anything.
All right.
Okay.
Perfect. Then we go over to a planning. I will be in the background answering your questions. If you have any questions regarding the mounting system here, please try the chat window, or also you can raise the hand virtually and we will open up your microphone. All right, let's go over.
Geht es so mit dem Mikro, wenn ich es in die Hosentasche stecke? Ja. Gut. So let's start planning a project in our planning tool Base On. This is the start page. Here on the left side you see 3 possibilities. We can create a new project, we can open an existing project, or we can get some help behind this question mark. For opening an existing project in your account, of course you need an account. You must be logged in, like I am logged in now as the user called webinar moderator. Okay, we have one first question, what the maximum roof angle for our Dome V system is, and it can be used up to 3 degrees and without a fixation. For more than 3 degrees you would need a fixation, and we recommend to use our old Dome system then. But for the V system without fixation, just as a ballasted systems, 3 degrees is the maximum until now. But the thing is, we are still testing and getting experiences, but we don't know yet if more than 3 degrees will be possible or is possible or not. But the testing is going on. Some more words about the setting. Up here you can choose your language. We have several languages until now, and you can choose between the metric and the imperial system. So let's first have a brief look behind the question mark. Here you find several help topics in text form and also in little pictures or videos. You also find these videos if you have a look on our YouTube channel. Don't hesitate, go through it, inform yourself. There are many good points, good help, which brings you on if you don't know base on too well until now. So yeah, let's just start a new project. Unsaved data for the current project will be lost. Okay. So the first thing we see here is a map. In my case, in this case, it's a map of Germany, and my pin now is in the middle of Germany. But probably I don't want to have a project here in the middle of Germany always, but sometimes, or in most cases, somewhere else. So I type in my address up here. I am in Industriestraße in Renningen. This is a Google Map based system, so I get a proposal here, Industriestraße Renningen. I take this, I confirm it, and now my pin is exactly here in the Industriestraße. You can see here, K2 Systems, this is where I am now. And I chose the Industriestraße now, but actually I want to plan a system on another roof. I know that it's close to here, so I have two possibilities. I type in the exact address up here, or I just go over there and I find my roof, and if I double click on this roof now, you will see that the address changes up here. So double click. Now I don't have the Industriestraße anymore, but the Benzstraße 43. I can give my project a name. I can type in my name here because I'm the author, and my customer's name, and so on. So many of you might have wondered if you are able to create a project on a not existing building. Yes, you can. You can draw your roof everywhere you want, here on the field, here in the middle of the street, or anywhere. It doesn't matter. If there is a river or a lake, you can still draw your building there. So let's go on. This is how we navigate in Base On, just by clicking on the site we want to reach. So first we want to create a roof. So we go to Roof. I take this plus here because I want to add a new roof. It shall be a flat roof in this case because our dome systems, Dome V systems, are flat roof systems. First we have a rectangular roof, and of course choosing tile, standing seam, trapezoidal or corrugated is not possible. I cannot click here. Only this one is possible. That means the surface of my roof is a typical flat roof surface like foil, bitumen, or gravel or anything. Yeah. So I click Add, and I scroll in a little bit with my mouse wheel, and I paint
I draw the first edge of my roof. I click again and then I finalize the roof. Now you can see here that all the angles have 90 degrees. One side is 23.22 meters and one side is 21.16 meters, and there we have a little arrow. This is the direction of my roof tilt, but actually my roof tilt is not into this direction but into this. So at the moment I don't have a roof pitch at all, but maybe I know that it's 1 degree. But as I said, not in this direction, but into this direction. So I use the minus or the plus here to alter the roof pitch. There it shall be. My building height is maybe 11 meters. My attic is 30 centimeters, and my friction coefficient, I know that because I measured it before, is 0.6. So now we see here an obstruction. We can paint the obstruction by activating the obstruction painting area. I have the possibility to draw polygon, rectangular, or just line shaped obstructions. This one is rectangular. The first edge of my obstruction always is parallel to the roof edges. So if I move my mouse, it just jumps rectangularly into another direction. If I don't want that, I can push the shift key on my keyboard and then I could have another angle too. If I take my finger off the shift key, then it jumps back to a parallel position to the roof edge. So now we finish our obstruction. Here you can see I can give my obstruction a height, maybe it's 50 centimeters high, and I can say I don't want any modules later on also 50 centimeters around my obstruction. And once I do this, you see the little shadow here. Unfortunately, I cannot zoom in more than now, but we can have a better look at it in some moments. Before we do that, oh yeah, let's just go to the 2D view now, because the 2D view offers us some possibilities we don't have until now. So because only in the 2D view we can type in the actual values of the actual measurements of the obstruction. Like here you see 11.02 meters. Maybe I measured before and I know this obstruction is 11 meters exactly, and it's 2.3 meters exactly. As well, I can now we have this function here activated, so the system shows me the length dimensions. I can also activate this function, then the system will show me the distances to the edge of the roof. So this is 10.25 meters, maybe that's right, and maybe this is not 6.44 but 6.45 meters. We also have the possibility to do this, not for our obstructions but for the roof itself. So I go to the roof and I now have to activate the length dimensions, and maybe we measured the roof before and it's 23.2 meters and 21.2 meters. Here I can say if the alternation has to take place at this
edge or at this edge or at both edges at the same time. But actually that doesn't really matter. But I want you to have a look now at these, at this value, 23.2 meters. But if we switch to map view, nothing happens in this case, so I have to enlarge the roof pitch a little bit. So now you see the difference. We have 23.23 meters, and if I switch to map view, I have 23.2 meters only. That's because in 2D view we have a view, a direct view on the roof, and in map view we have a view from space, so to speak, from the satellite. And that's why, because of the roof pitch, the edge seems to be a little shorter from satellite view compared to the 2D view. But as we said before, we want the roof to be 23.2 meters. Yeah, let's do 1 degree again here. So we wanted to have another look at the obstructions. Here, this red area around the obstruction is the edge distance. Here must not be any modules later. We can of course alter it, 20 centimeters or maybe 1 meter. We also have the possibility to show the shading. Default value here is the 12th of December between 10 and 4 p.m. We see the shading, and we can use this function to delete modules, shaded modules later on. Down here you have the possibility to type in some remarks, maybe to tell your customer, hey, please think about or remember that some values or some informations are still missing. So you can tell that I don't know, the building height is still missing or something. Yeah, then your customer will know, oh yeah, there was something I have to tell. They have to tell you the actual building height. Okay, let's go on to design and draw a module field. Here first you see that you have to choose a module. We have a list of several manufacturers here, and once you chose your manufacturer, you can choose the module, or if your module is not in here, you have the possibility to choose user-defined. You can give your module a name and type in the actual measurements of the module. Then we can go to this area, module array, and add a new module field by using this plus button. We want to plan a dome V system. We have dome D-dome V or S-dome V. Also, of course, you could theoretically choose one of our classic dome or flat roof systems, S-Rock, S-Rock Short, D-dome or S-dome. Now I will choose D-dome V, and as soon as I do this, elevated and landscape is chosen, because it's not possible to use a dome system parallel to the roof surface, of course, and portrait clamping is also not possible. But we have to choose if we want to put modules on the complete roof, or if we want to make a module field. Even if you want to have a module field on the complete roof, I still recommend to use the module field option, because later on in many cases you need to be flexible, and you are definitely more flexible when you use module field in most cases. The more complicated a roof is, the more obstructions you have, the more areas you don't really use, or more obstructions you have, you are always more flexible by using module field. So I click on add, and then I want to put a module field over the whole roof, so I'm just doing it. I start and I stop within the yellow line. The yellow line is the edge distance, which is by default 60 centimeters, and it has to be 60 centimeters at least. You can see it here. It's not possible to type in a smaller value like 0.4. It will always jump back to 0.6. But of course you have the possibility to make the edge distance larger. That's no problem. And then you see that the yellow line is not at the same position anymore. It got more into the roof. Let's go on and have a look on the other functions later on, maybe. Just two little things. Now you see here the number of modules in this module field, and you also see the output power. So let's talk about the first value up here. It's the row spacing. It is 2 meters and 13. That's the distance between beginning of the module to the beginning of the next double module, because in a D-dome system we always have double modules. Yeah, so this is 2 meters and 30 centimeters from here to there. That means that you have a little bit of space, like 10 centimeters between these two modules, so you can place a foot here. You can get the modules closer together, but you can also put it further apart. But if you do that, it always can happen that you lose one column of modules, like here. You see, we had more modules before, and we have only 144 now. I go back to the 2 meters and 13. Okay, now something else changed. That can happen. Let's try 2 meters and 12. Yeah, now we have the 166 modules again. Let's try to type in something like 1 meters and 80, which is not possible, and again the value jumps back to the smallest possible distance, 2 meters and 5. So I recommend to always have a little larger distance here, like 2 meters and 20, for example, if it's okay for you and you don't lose any.
I think
module
there is a
columns.
question that fits very well right now. Why isn't it possible to make edge distances shorter? It's the yellow line, right?
Yeah. Well, this has to do with static verification of the system. You get the static verification in this case because we made intensive wind channel tests, and the wind channel tests, or the results of the wind channel tests, they say that we must not place any modules too close to the roof distance.
Yeah.
There you have an extreme high pressure and suction caused by the wind.
Yeah,
and
it's a very dangerous area actually, because you have turbulences. You have suction and pressure at the same time sometimes. So it's definitely recommended to stay away for, what is it, 1 meter from the edge.
60 centimeters.
60 centimeters is the smallest value. 60 centimeters, yeah.
So it's almost not possible to place enough ballast in this area if you had modules there. Yeah. Outside. Okay, let's just have a look to the results. We just head on to the loads page, and there you see that our wind load and snow load is already calculated, yeah, and that's because we have the Eurocode with national attachment of Germany, and I typed in the address of my project, so I have the actual values for my project already calculated here. Might be in other countries that we don't have a national attachment, then you would have to type in your values manually or in another way. That depends. The rules for different countries are also different here sometimes.
So we are really implementing the national codes and the national standards step by step. So recently we implemented Sweden, Poland, Hungary. Step by step we're completing the whole list of European countries, but also international countries. So yeah, after all, the only thing you have to do in this case on this site here is to choose the right terrain category. Default is category 2/3. That means open fields / industrial or commercial areas. But if we go back to project and zoom out a little bit, I think we can say, okay, this is an industrial area, although here is an open field, but still we can choose category 3 here. And then this value might change a little bit in many cases. Let's have a look. Yeah, something happened here from 0.51. It goes down to 0.48. Okay, let's go on to the result page. Here we see on the left side some values we can alter. We come to them later. And here in the middle we see our ballast values. We see our module field and the ballast values. In this area we have 0 ballast. Here we have a little bit, here we have a little bit more, but here the values are even higher, and this is the highest value we have. We see that immediately because it's yellow. The more it goes into yellow, orange and red, the higher is the ballast. So how is that? Why are all the values so different? That's just because of the situation, because of the place the modules are, and because of some thermal cuts the system sets automatically. So I would like to have a more homogenic picture here, more homogenic ballast values. I know that, or we can see that here we have a thermal cut, and also here we have a thermal cut. Let's go back and have a better look on that.
back to design. I switch to the 2D view because it's easier to see then. And we can now edit the thermal gaps. You see that we have to have a thermal gap every 7 modules. So 1, 2, 3, 4, 5, 6, 7, and horizontally after 9 modules. It always counts from the left and from downstairs, or from the downside of the screen. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 2 possibilities now. We can say, no, I don't want it after 7 modules, not here, but we could place the thermal gap here or here or here. That would be good places. Let's just, and now we could say 1, 2, 3, 4, 5, 6 after 6 modules. This would be a possibility. Let's do 5 first. But that would mean on a bigger roof that I have a thermal cut after every 5th module. Maybe I don't want it. I want to leave the highest possible distance. And if I try to type in a very high figure here, like 10, then it jumps back to the highest possible distance, 7 modules in this case.
So one interesting question was, and that totally makes sense, that here the shadow is covering a couple of modules, and it would be great to push them a little bit higher out of the shadow. Probably you can also show us how to do that.
Yeah, we'll come to that in 1 second. Yeah. Good question, thank you. But first I want to show you how to edit single thermal gaps. So now we have the thermal gaps here, and I want to place it here now. So I just click here, then this red line gets yellow. That means, okay, I can work on this line now, and I set a hook here because I want to have a thermal gap, and afterwards it's calculating. I have to wait a little bit. So now I have my thermal gap here. The yellow line got as thick as this one. Now I click this one and I remove the hook because I don't want to have a thermal gap here. I also have the possibility to edit this thermal gap, but maybe I want to leave it here because, yeah, the ballast could be more homogenic, the ballast values, but also if I leave it here I can save some material maybe, because every gap means that I need more material in the end, and as I have a gap, so to speak, here already, I can use this situation to save or not to use more material afterwards. Yeah, I can just show you that. If we have a look on the summary, this is our and let's have a look on the ballast values before. Now you see it got much more homogenic. Yeah, we have lower values now, no yellow values like 51 kilograms as before, and up here it also is a little lower. We had 28 or 30 kilograms before. Now we have only 21. So this looks really good. I would say that we can leave it like this. Let's go to summary and have a look on the bill of materials. Here we have the parts for the dome V, and we see that we have 87 large of the dome bases and 174 of the dome V peak parts. If we go back to design, what I said before, we alter this thermal gap and put it here in the middle maybe, then we will need more material in the end. Yeah, the ballast values, they look also very good, okay, but oh no, we have the same amount. How's that? Oh, yeah, of course. Yeah, but in some cases it could be that you can save material by putting the thermal gap into the right position. So let's have a look to the situation you asked before. I have a little shading here, yeah, and I don't want the shading, so I have two possibilities. I could delete these modules, but as we can see, we still have some space here, so we have the possibility just to leave the modules. Yeah, we don't have to erase them. We can also move the whole module field a little bit more up. So I first have to click into the module fields until I see the white dots in the edges. Then I can move it a little upwards. Still a little bit of shading, so 1 more millimeter. Yeah, now it's out of the shading. So this is a good situation. So we go back to results, summary, and yeah, don't forget to save your project from time to time. It's saved now in your account, and you also have the possibility to download the project file. Maybe you want to send it to us, or you want to send it to your colleague who has to modify something next week when you're on holiday or something. Or maybe your customer wants to have a look on it also and modify something. You can do this by downloading the file on your computer. You also have the possibility to generate your static report here. So let's have a look in the static report. Here you have all your project data, address, building, factors, wind loads, module sizes. And there you have your module fields. We have 4 blocks, 1, 2, 3, 4. For each of the blocks we have more details here. Like block 1, for example, is 13 meters and 10 and 8.4 meters. And here in orange you see that we have different rails, shorter rails and longer rails. And there you see that it's very important that this report will be on your roof while the plant is getting installed, because only with this plan the installers know which rail they have to use in which position. Same here. We have the ballast values for every block. In some points you don't have to put any ballast. Then you have more details about the specific loads, the maximum values, and the weight of your total of your whole system. Here we see how much ballast we have in each block, and here we see the whole weight of your system. And we go down a little bit. We have some more detailed calculation, and then the confirmation that our system has been successfully calculated. And in the end, you also have your bill of materials, and as you can see, we don't have any additional item for ballasting, because our ballast values are so low and can be placed directly onto the rail.
So, because there was also a question regarding this, maybe we can have a look in the PDF file again. So the PDF is what you get as a result of your planning, and the question was regarding the maximum load value on the roof. So with this report, you can contact the statistical engineer or the architect of this building. He knows how to work with these numbers that are here in the report. And for you, very important is the value of the load. I will scroll down here to this table here, specific loads. So here you will see what is the load value of the system and what is it in total including the ballast. So the dead load here is the most interesting number, 0.14. You can compare this number with the number that the roof allows you to put on. Yeah. All right.
Let's go back to base on, and I can show you then the last two positions here, the last two possibilities of downloading. One is a bill of material as an Excel file. Let's just have a brief look. Nothing special, but you can use this downloaded Excel file just to make your request, just to ask for an offer at your supplier. Of course, you can modify, add some articles, or alter here the needed amount. Actually, you could also edit the BOM in this place. You can say, oh no, I don't need any mini clamp end clamps because I have plenty on stock still. Yeah. You can also add additional articles here and then apply, and then you see your modifications in the bill of materials. Also, you can download the ballast plan as an Excel file. It might help you to buy the required ballast stones. You can count, for the Excel experts, they can count how many times the value of 1.5 kilogram appears in the file. Or of course you can also make your string planning in this Excel file. So finally we came to an end. That's what I can show you until now, but of course you are welcome to ask further questions.
Yeah, you can take your time. We will still be online for a while, answer your questions. Anyway, you can also find, we will send you the link to this webinar, so later on you can also, if you want to be reminded, you can look into it again to see some details. We also have on YouTube a lot of tutorials how to use Base On, and also an introduction of our products, and we always keep it up to date on our homepage under the category of news. We will always upload product news and or exciting projects that we realized.
Yeah, thank you very much for taking part in the webinar. I hope you enjoyed, and I hope you learned something. And yeah, I wish you much fun in using
Happy
JSON.
planning.
Happy planning.
All right.
Thank you. Goodbye.
Take care, guys.